For this assignment, our group members are Yao Yuhian, Tan Qi, and Tan Weiyuan. For this assignment, our topic is about magnetic circuit. A magnetic circuit is a closed path containing a magnetic flux. The magnetic flux phi through the cross-section of the core A can be determined by Ampere's circular law. Referring to the figure below, a coil of N turns carrying a current I is wound on this ferromagnetic core.
For this field theory assignment, in question number 1, we can know that the number of turns of the coil is 300. The mean circumference is 400 mm. The area is 500 mm square, and the current flow through the coil is 4 ampere. To find the magnetic field strength, we can use the formula H equal to N multiplied by I. N, which is the number of turns per unit length. To find N, we can divide 300 by 0.4, which will give us the value 750. By substituting 750 into the equation, we can get the value of 3000 ampere per meter, which is the magnetic field strength. For the magnetic flux density, we can use the formula B equals to U naught multiplied by H. U naught, which is a constant, gives us the value of 4 pi multiplied by 10 to the negative of 7, and H, which is the magnetic field strength, is 3000. By multiplying both of the value, we can get magnetic flux density for the value of 3.77 times 10 to the negative of 3t.
In part C, we are required to find the total magnetic flux. It could be calculated easily by using the formula phi equals to BA, where B refers to the magnetic flux density that we obtained above. A refers to the cross-sectional area. By substituting these two values inside, we could get 1.885 microweber.
So now I'm gonna show how to solve the question 2. Figure 1 below shows a wire and a metal rod. If the metal rod moves with constant velocity of 5 meters per second, 5 V12. So what is V12? V12 is actually an EMF induced by motion relative to a magnetic field. We can also call this as motional EMF. So how to solve this question? So to solve EMF, we're gonna use this equation, which is L, the length of the object moving at the speed v, relative to the strength of magnetic field V. So if we look at the diagram and the question, we actually have two constants, which is our velocity 5 meters per second and our magnetic field. The only changing is our length, so we're gonna use differentiation to solve this. So we're gonna rewrite our equation at this v, which is our constant velocity, and the equation of our magnetic field. This is magnetic permeability, and I, which is our current, divided over 2 pi r, and the changing of our length, which is the area and length plus our area. And we're gonna put in the value. We're gonna look like this. Phi, which is our constant velocity, 4 pi times 10 power of negative 7, which is our magnetic permeability, 10, which is our current, and over 2 pi times the changing of our length. And we're gonna write our equation like this, represent the differentiation of the length. And after solving this, we're gonna get the answer of 13.863 microwatts.